Buckle up, space fans. Let's dive into the mind-blowing world of black holes. But first, what's the real deal with these cosmic monsters? Imagine a super powerful vacuum cleaner in space. That's basically what a black hole is, but instead of sucking up dirt and dust, it pulls in stars, planets, and even light. It all started when a massive star collapses under its own gravity. This incredible collapse creates an intense gravitational field so strong not even light can escape once it gets too close. And that's how we get a black hole. Let's break down this mind-blowing concept. A black hole isn't actually a void or an empty space. It's more like cosmic overkill. The gravity within is so extreme that it surpasses light speed, making it impossible for anything to escape once it gets too close. Imagine the ultimate density. A black hole packs in more matter than anywhere else, squished into an incredibly tiny area, essentially warping our understanding of space itself. Get ready to dive into space and explore the mind-blowing world of black holes. So, you might be wondering how these cosmic powerhouses are created. Well, imagine an explosion of epic proportions. We're talking about supernovas, exploding stars that go supernova when they've got around 25 times the mass of our sun. When this massive star reaches its final breath, it's like a cosmic burst. The outer layers blast off into space at incredible speeds, but what's left at the core starts to implode, collapsing under an intense gravitational force. If enough mass is packed into that shrinking core, gravity takes over and a black hole is born. Get ready to blast off into the mind-blowing world of black holes. When a massive star goes supernova, what's left behind is an incredible cosmic heavyweight, a stellar mass black hole with a mass that's several times bigger than our very own star, the Sun. But wait, there's more. There are two types of these space monsters: stellar mass black holes and their gargantuan cousins, supermassive black holes. These gentle giants reside at the centers of galaxies and pack an astonishing punch, with masses that can reach millions or even billions of times that of our star, the Sun. Here's the thing about black holes. They might have formed around the same time as their galaxies, but let's get to what really matters. What if you got too close? You'd be done for, no doubt, but it's not a super slow death by gravity. It's actually more like your demise would happen way before you reach that point of no return. That's because the gravity from an object gets incredibly stronger as you get closer. So strong it'd crush you in a snap, before you even had a chance to take that fatal plunge into the black hole. Imagine getting closer to a super powerful stellar mass black hole, headfirst. As gravity's grip tightens on your feet, it becomes a whopping thousands of times stronger than on your head. This intense force starts stretching you out like Play-Doh being pulled apart, a weird effect scientists jokingly call spaghettification. By the time you reach the black hole, you'll be a long, thin string of matter stretching for miles in space. But surprisingly, it's said that this gruesome transformation might not even hurt. Imagine you're in freefall from space, plummeting towards a cosmic monster. But don't worry, it's all over in the blink of an eye, just milliseconds. Unless, that is, you get intercepted along the way by a black hole with an insatiable appetite. These space vacuum cleaners snatch up nearby stars or gas clouds in their vicinity, feeding on their matter like unstoppable cosmic predators. The stolen material forms a swirling disk around the black hole, known as an accretion disk, where it zooms at breakneck speeds and reaches mind-boggling temperatures of millions of degrees. Get ready for some mind-blowing facts. If you were to get too close to a black hole, it wouldn't just suck you in. The intense X-rays it'd blast out would incinerate you before that even happened. Now let's dive into the different types of these cosmic monsters. We've got intermediate black holes packing 100 million to 100 zillion times our sun's mass, supermassive behemoths with masses rivaling billions of suns, and microscopic ones weighing at least as much as 22 micrograms. But here's a question: can a black hole actually blow its top? Black holes are cosmic vacuum cleaners that suck in everything within their grasp: stars, planets, even light. The laws of physics as we know them go out the window near these mysterious behemoths, and scientists can't yet give us a clear picture of what's happening inside. One thing's for sure, though: once you cross the event horizon, there's no escape route. Black holes are notorious keepers of their ill-gotten gains. Get ready for some mind-blowing facts about black holes. Scientists discovered that no matter what these cosmic monsters eat, or how you treat them, they just keep growing. It's like the ultimate growth spurt in space. But here's the twist. Stephen Hawking had a theory that even though black holes get bigger, they actually release tiny amounts of energy, which we call Hawking radiation. Now imagine if your biggest worry was slowly disappearing over billions of years, but only if you're super small and start with zero snacks, because surprisingly, even tiny black holes can eventually evaporate into thin air. Let's dive into one of the biggest mysteries, the Big Bang. Here's what we know at its very beginning. There was this thing called the singularity, and honestly, it's still a total enigma. It's basically a point with no size or shape, and it's hard to wrap our heads around that. Some theories like string theory try to make sense of it, but they're just educated guesses at this point. Think of them as cosmic what-ifs. Now, math can help us understand what happened super fast after the singularity started expanding. We call this inflation. But when it comes to the very starting point, sorry, that's still a total mystery. Alright, let's debunk a myth about black holes. They can explode, but there's actually a mind-blowing way they meet their demise. Black holes don't blow things apart. Instead, they suck everything in with an intense gravitational pull. Now imagine if one were near Earth. It'd be catastrophic, as our entire planet and all life on it would get sucked in, leading to a total wipeout. But here's the cool part: over time, under the influence of Hawking radiation, a black hole could potentially transform into its opposite, something called a white hole. A white hole is like a cosmic ejector, blasting everything away from itself instead of pulling it in. What a fascinating concept to wrap your head around. That's a wrap. Thanks for tuning in and expanding your knowledge with us. If you're loving this content, hit that subscribe button and the thumbs up icon to show some love. Don't miss out on our next exciting video. Just tap the link below to explore similar topics and keep learning with us.